Here's a problem I want to work out. A student asked about this, but he had already solved it, so good job for him. But it's about doing partial fractions and doing this telescoping series. And the way telescoping series works is you end up with the middle terms end up canceling out. And I want to show how to get this into this format right here. How to convert this series into something that would be a telescoping series by using partial fractions. And that's really the gist of what I'm after here. I mean, we can talk a little bit about evaluating this series. If you were to look at several terms out, we'd have, like, for n equals 1, we have 1 over 1 squared, then minus 1 over 2 squared. Then plus, for n equals 2, we're going to have 1 over 2 squared minus 1 over 3 squared. And then for n equals 3, we're going to have 1 over 3 squared minus 1 over 4 squared. And you can see as this continues out, these terms are going to be canceling out. This cancels out with a future term, and the only thing that's left is this 1. So that's why this converges at 1. But what I want to show you is how to make this look like this. And using some of the skills that we've already learned, it may not be obvious in getting there. So starting with this 2n plus 1 over n squared plus n squared. It's real tempting to go ahead and do an n squared plus n and then an n squared plus n squared with the respective 1 degree lower terms on top. But there's a reason we can't do that. It's because this isn't factored. So if we look at 2n plus 1 over, and I can factor out of each of these terms in n times n plus 1 quantity squared like that. So I'd have a 2n plus 1 over n squared times n plus 1 squared. And then we can break that out into our an plus b over the n squared, plus then a c over n plus 1, and then a d over n plus 1 squared. So again, what we normally would do, we would clear out the fractions. So we multiply everything by the common denominator of the n squared plus, or times n plus 1 quantity squared. And that gives us on the left side a 2n plus 1. And on the right side, it would be an a n plus b times the n plus 1 squared, plus then c gets multiplied by an n plus 1 and an n. Then d just gets multiplied by the, it's an n squared. Oh, it's just an n. Should be an n squared. And then d gets multiplied by just the n squared. Okay, so I need to do a little bit of algebra here just to expand this a little bit. So we have 2n plus 1 equals an plus b times our n squared plus 2n plus 1. Oh, let's just erase and fix that. Sorry. N squared plus 2n plus 1 plus, here we have cn cubed plus cn squared. And then we have our plus our dn squared. So we have 2n plus 1 equals, I'll have an cubed plus 2an squared plus an plus bn squared plus 2bn plus b plus cn cubed plus cn squared plus dn squared. Okay. And the first thing I notice is that in terms of constants, on the left I have a 1, and on the right I have a b. So right off we know that b must be 1. Now if we look at our n terms, on the left we have a 2. On the right, okay, a is with an n, 2b is with an n, and that's it. So that 2 equals a plus 2 times 1. I don't need the n here. Sorry about that if I confused you. So that a must be 0. Okay? It's good to know. Now let's go on to our n squared. So we did a constant. We did the n's. Let's look at n squared. For n squared, on the left we have a 0. On the right we have a 2a, which we know a is 0. We have a b. We have a c. And we have a d. Okay. We can clean it up a little bit because we know that's 0. But we don't know about c or d yet. We know b is 1. So we could write this as 0 equals 1 plus c plus d. And our n cubed, we have a 0 on the left. And then on the right, what do we have? We have an a, which you know a is 0. We have a c, a plus c. Well, we know that a is 0, so c must also be 0. So here we know c is 0. So that means that 0 equals 1 plus d, so d must be negative 1. So if we go back up to our structure here, this here, bring it down, we will have 1 for the b over n squared plus negative 1 over n plus 1 squared to get what they have, 1 over, or this student has, good job, 1 over n squared minus 1 over n plus 1 squared, like that. And that's how you do that decomposition. So hope you enjoyed that. Hope that brought back some fun memories. And let me know if I can help with anything. Thanks.